Okay, so good morning, everybody, and welcome to another episode of Environmental Social Justice. Today we have a very special guest. We have Ciarán Smyth of Bala Consulting Engineers. Almost got the name wrong, Consulting Engineers. And what I love about what you guys are doing is you're so focused on sustainability and the environment. And even though you are the lead for transportation, you work a lot in the built environment. And I actually had to look up some of the things you do, even though I consider myself knowledgeable in construction. I did have to look up a few things. So one of the things is embodied carbon, which for people who don't know what that is the carbon footprint left behind from construction. And then operational carbon impacts, which is the carbon footprint caused by the operation of the building. So Ciarán, please tell us everything you're working on and how you're trying to fix this. And if I must say, if you build it, they will come.
Yes, well, first of all, thank you very much for having me on the program today. I really appreciate it. My degree is in building services engineering, which is what we call it back home in Ireland. We call it MEP over here, which stands for mechanical, electrical, and plumbing. So we do all of the services that keep buildings running. So, we like to think of as the heart. We're the ones pumping the fluid around the building, the air, all the pipes that carry the water and things like that in a building. And in the built environment over the last sort of 10 to 15 years, we as MEP engineers have been very focused on the operational side of things. In other words, how much electricity, how much gas, how much water, things like that the building's using. We've had a really big focus on energy, and so codes around the country have been adapted or are being adapted to reduce energy impacts. How much electricity does your air conditioner draw? That type of stuff. And we as designers utilize the best platforms that we can. We use things like Revit, which is a BIM information modeling program, to draw our pipes and our ducts in, shorten distances, try and work with architects on how a building is made up. The skin or the facades of building is very important for us, because that's ultimately what lets heat in and heat out. So if we can have a well-designed, well-orientated, well-thought-through skin, we have a really good opportunity to reduce the sizes of air conditioners or boilers to cool down or heat up buildings. And that's been the operational side. What's come to the fore over the past few years is the embodied carbon, which is the carbon associated with the materials that actually go to build up the building, including the pipes and the ducts, how they're mined, how they're made, their lifetime during the project and their lifetime after the project. And so structural engineers and architects are getting more heavily involved now in the carbon side of things, because the embodied carbon is really to do with the bones of the building and the materials that make up the building. And so we're trying to design buildings now to reduce the amount of embodied carbon, or to use better materials that have less impact on the earth. And it's starting off. For me, I've only started to really look at this in the last 12 to sort of 18 months, if I'm honest. Because on the MEP side, there's not a whole lot of data, but there's a ton of data on the structural side and also on the material side for architects. So architects can now go and choose materials that they know have got an environmental product declaration sheet that lists where the materials are coming from and their impact on the environment. So, as an industry, we're really moving forward, and it's great to be a part of it. And it's not just on the design side either. Contractors are stepping up to the mark, which is great to see.
Yeah.
Because in the built environment, there's sometimes a disconnect between the design side and the built side. I'm sure if you've ever had some work done in your home or something like that, there you had to work with a contractor, something always comes up. Construction has one of those, there's some hidden stuff everywhere. So, there's only so much that we can do and foresee. And then when you come up with an issue, then you just got to work through it. But it is good to see contractors understanding the embodied carbon and the operational carbon. They're looking at their supply chains. So any of the products that we would specify, like a boiler or a fan or a pump or something like that, they're looking to see where those are being derived from. So we're definitely going in the right direction, but still lots of work to be done.
So, it's great to have you on the show, first of all, especially as I'm going through design build right now with an ADU unit that I'm trying to put together on the back of one of my properties. So the big thing right now is the volatility of wood, right? Since there's been such an issue with everything going on with COVID, the commodity of wood for building has really been one of the negotiating price points that contractors have been using. You better buy or do an ADU now because the price of wood is going to go up. And then I hear on CNBC the other day that it's going to drastically drop. What about some of these other building materials that are newer, that are supposed to be more environmentally friendly? And is wood still, the foundation of building, or what are they doing as far as treating of wood, or what are some of the efficiency products that are being used right now?
Yeah, I mean, I'm not a structural engineer, but that's a great question. I can tell you that timber, obviously with being a home, people going to their local Home Depot or whatever, they're buying lots of it, and obviously the price is rocketed up. Timber is an incredibly environmentally benign material for buildings. And when people think of timber buildings, they think, oh, well, it's a fire risk. But you can treat wood in a particular way. So there are lots more timber buildings being built now because of this whole embodied carbon. It has a much lower global warming potential footprint as, let's say, steel or concrete. I wouldn't know the specific numbers, but steel, concrete are traditional forms of building, but timber is definitely coming back, and it is a specialized material. So, the structural engineers, I remember one of the firms that I used to work for, they had a dedicated person just for timber, because it's put together in a different way than, say, steel or concrete. But timber is really being used right now, not so much for high-rise buildings. I think the tallest building, I think might be somewhere in Minnesota, is maybe 7 or 8 stories.
That's awfully high for timber.
I think so too. And it's a beautiful material. You can leave it exposed and it looks great. But yes, it can be treated, so there's no fire risk there. Part of the issue is getting it through codes. Some jurisdictions allow it. I think some are a bit more standoffish to it. But people on the structural side of things, on the design side, are definitely looking more at timber because of its pros in terms of embodied carbon. So it's definitely something that's being used for sure here in the States and over in Europe and around the world.
Yeah.
So I have 2 questions for you. One, I kind of want to go back to, so you're working on a lot of new construction. What about, so I know a lot of people are turning abandoned or unused office buildings, those are now being renovated for housing. But the problem with that is that they were never designed for that. So a lot of them were deemed sick buildings because you don't have the proper airflow. People would be in their units, they can't open windows, so you had a lot of illness that was starting to happen from that. So one, how do you address that? So I'll let you, and then I want to talk about what you think of prefab and modular housing. And
wow. Two fantastic questions. In terms of the first one, again, I'll go to the embodied carbon. The best building for embodied carbon is one that's already there, because its carbon footprint is already done. Right. So adaptive and reuse of buildings is becoming way more popular now, particularly in older cities. When you look at places like New York, DC, Boston, Chicago, LA, in certain places, it requires a lot of thought up front on the design side, because, like you say, certain buildings that are designed for an office won't have the same sort of infrastructure setup that they would probably be required for an apartment building, let's say. But that's not to say that with some clever design and some proper coordination that we couldn't get things like that in. One of the big things that's going on right here in the Northeast is actually office to lab design. So buildings that were designed for offices are going to now labs, which, given COVID, there's a big push on that. So it's very different for an office building across all different disciplines. So structurally, an office building probably wouldn't have been designed to hold the weight of a lot of the lab equipment. So you would need to ascertain whether that building is actually good for equipment to be moved in the first instance. If it is, then we'd go to things like water, air, and heating and cooling. Do we have enough of that infrastructure in place? And I've seen buildings up here in Boston where they've run ductwork outside the building because they can't run it inside the building because there's no room to run it inside the building. So there's a couple of different ways that you can do things, and it mightn't look fantastic for architects or things like that, but depending on the building itself, we can come up with clever solutions to be able to turn one building from an office to a lab or an office to an apartment. So and again, I'd go back to the design build side of things, which kind of leads into the prefab. When you're working with a contractor very early on, this is just an opinion of mine, I think you've got much less issues later on. We need to bring the people who build the buildings on board earlier. We're designers. We're not builders, and there's a whole series of sequences that need to be thought through about, well, which crew comes on first, which discipline goes first. Contractors have that knowledge, and I'm not saying we don't have it on the design side, but they're the experts on it. So if we can bring them in earlier in a design, they can help and influence the design so that later on we're picking up efficiencies in time and in cost. I think that's a good segue into prefab. I'm a huge fan of prefab. I think there's massive potential for prefab in this country. And during COVID, one of the massive advantages, I think, for prefab was that you can get a building built in a controlled environment. So people are going to a safe environment like the warehouse where they build things. They're not going out on site. So you have less security issues. You can control the people who go in and out. So you can control, whether people are sick or ill or things like that. You tend to get a lot of efficiencies there. Some of the projects that I'm currently working on, I was delighted to see that the mechanical, the electrical, and the plumbing contractors, when we were in D-scope meetings, every one of them brought up, we will be doing as much prefab as we can. So let's say, a row of toilets in a public bathroom, they can pipe up all of that pipe work in the shop, bring it in, put it in, trolleys that can go up and down, and then just click it together, which saves them a lot of time. And again, they're working in a controlled environment in their warehouse, in their shop, and then they're just bringing it to site. So there's the efficiencies that they pick up there. I think it's got huge potential for things like affordable housing, which it's been used for. There are multiple hotels and things like that in the UK where, if you think of shipping containers, they just stick together. They're like for apartments, they can have a room and the bathroom already made, and then they click together like Lego. I think they put up a 4-star hotel in like 4 days. It's just incredible. So I see a lot of potential there for it. It's not for every building. I don't think you can see it in high rises, but we should definitely be looking at it in where we can, because there's also an efficiency of waste. There's much less waste when you're putting things together in a shop because you're able to plan ahead. Whereas when you're out on site, sometimes you might have to rejig things, cut something back, and the whole measure twice, cut once, not necessarily coming through on site, because you might have a field condition that just happens to be that wasn't planned for. And so you've got more opportunity on the prefab side of things to avoid things like that from happening. So I'm a firm believer in it. I think there's going to be a lot more of it.
Definitely.
And again, if it works and we produce the building to the same standards and the same requirements, why wouldn't you do it? If it's going to save time, money, and if it's going to cut down on waste, which is also very important.
And there are some some incredible companies that are doing, when it comes to residential, they're doing beautiful jobs. They're spectacular what they're creating, and they're for a fraction of the cost. And correct me if I'm wrong, but one thing which I've read years ago, and I don't know if it's, sorry, my dog is sneezing, is that structurally, especially in Southern California, they could be a better fit because they're going to be potentially more sound than a normal on-site wood built structure because of the transportation to get them there. They have to be built different to withstand the shaking.
Vibrations?
Yeah, exactly.
Yeah.
So you're going to have a bit more of a structural sound. But there's another company I've seen where one thing that they did, which I thought was brilliant, is they created a center control unit or panel. So all of your plumbing and electrical, there's a panel on the outside. And if you need to ever have, if you have a plumbing repair, you don't break through a wall. You don't do anything. You literally go through a panel outside, you climb up a ladder, and every single thing, the hub is right there for repairs. And it's one of the smartest things I think I've ever seen, and beautiful. It's, yeah, so, and then there's the 3D printing homes. I know there was a whole bunch of stuff that's happening right now, which is, it's really cool stuff. It's really cool.
I completely agree. I think the construction industry is going through some huge changes. I think technology is driving those changes as well. You know, I mentioned earlier BIM, building information modeling, which is, you know, when I started, it was all in CAD. It was 2D, and then you had to think about your
I forgot about
your
that.
sections. It's not like that anymore. We're actually working on platforms live with the architect, with the structural engineer. We're able to draw our pipes, our ducts, and coordinate them with the structure, with the architecture. And virtual reality is starting to become more to the fore, where we can actually put our model together, put on a set of glasses, and then walk through the building. So we can see, so we can see,
awesome.
Hey, there's a clash there. That pipe is hitting with this. We should change that. So before it ever gets to site, before anything is ever, any pipe is, or duct or beam or column, we're able to with better accuracy now with these types of platforms, we're able to pick up issues before it even gets to site. And again, it that's what makes it efficient. It cuts down on time, cuts down on cost, and again, I'll use the third one. It cuts down on waste as well, which is what we don't want to be using materials just to take them out. Right?
Oh, yeah.
We want to use what we need and only what we need, and that's going to help the planet, and it's going to help the building as well. So, yeah.
And just to add in, because insurance nerd, got to add, did 20 years in insurance, construction insurance specifically, but I would think that the errors and emissions and construction defect claims would go down with all these new technologies coming through and the prefab and virtual reality. BIM was, I remember the first conference I went to where they talked about BIM, and I was like blown away by it. This is going back a few years. And all of these advancements, so you now have, you're cutting back on your costs, you're cutting back on your waste, you're probably cutting back on your risk.
Yeah.
This is brilliant. I mean, everything you guys are doing, obviously we're huge fans of, and Joel hit the nail on the head with the whole shipping containers, because Joel was one of the first, well, I underwrote one of the first shipping container sites 15 years ago. But people were afraid of them. They thought they'd be contaminated. They thought that they would have problems with them. It's like, it's steel. And they're structurally sound. And Joel has sent me some beautiful renditions of what people can do with shipping containers.
Absolutely. I think, you know, people are always, well, not always, but people are afraid of things when they're happening for the first time, right? Because they don't know. There's no precedent there, and there's no understanding of what it's going to be like. You know, in terms of how buildings are being built now, there's a lot more thought going into them. There's a lot more ideas being floated around, and again, we're able to use these platforms to test things out, to understand whether they're going to work or not. You know, I look at something like LEED, right? When LEED came in, you know, leadership in environmental energy design. Sorry, I always get that mixed up. When that came out, everybody was scared that it was going to skyrocket prices, and I think in the first part of it, it probably did. But now we're seeing things like on you know, studies that are being done for net zero buildings, for example. When people hear that word or hear those words, like, oh, cha-ching, you know, lots more money, and it's not. There's studies that are actually being done, excuse me, up here in Boston. Where they saw it's only 1 to 2 or 3% difference in cost, because again, the whole industry is accepting that this is where we're going to go. At the end of the day, we want to build efficient, appropriate, healthy buildings, and once we can specify the right equipment and the right materials, we don't see huge added costs, and the benefit for the end user is so big because they've got a proper, healthy, you know, efficient building that's trying its best to reduce its impact on its location. So,
and that's just it. I mean, if you spend the money up front, eventually eventually, I'm not saying anytime soon, eventually, it does pay for itself in the long run. So, if you invest it now, yes, that it's just a fact. We all know as these technologies are new, they always cost more. It's, so the very first people who do it, they are going to pay the inflated costs. And then as that technology becomes more common and prevalent, that's when the prices start going down and it starts coming in with everybody else. So, but the long-term benefits are really what you're paying for up front.
Yep.
Absolutely. I would use, photovoltaics as a perfect example of that.
Oh, yeah.
When they first started coming out, incredibly expensive, right? Very expensive. And probably still so, but there are like deals out there, I suppose, that people will install them for you, and they are coming down. Remember when computers and laptops came out, they were like $1,000 or $2,000 or whatever, and now they're like $400 or $500. I see the same thing happening with PVs, and I will bring Elon Musk's idea into it, where he actually just, instead of building a roof and then sticking something on top of it, why don't you just make the roof?
Thank you.
The PVs, right? What a clever idea. You need a roof, you need the material, and now we got the PVs. And in the end, yes, it's a little bit more expensive, but now if you size it correctly and you design it correctly, you don't have to pay electricity. And I look at a place like Texas, which is going through another, right, in the winter, they had their blowout because of the freezing, and now they're having another blowout because it's too hot. So,
I love it when people blamed Texas and said, oh, windmills, wind turbines don't work. It's like, they didn't winterize them.
Yes.
So,
and again, that's a design flaw, right? There's a great quote from Dr. Ralph Speth. He's the CEO of Jaguar and Range Rover. And he says, if you think good design is expensive, you should look at the cost of bad design. And I absolutely love that quote, because it's so true. And it doesn't matter what industry. They're in the car industry. Can you imagine getting the design wrong and offshooting 10,000 cars? The cost of that. Buildings are no different, right? They're very unique things. Buildings, for the most part, they are anyway. But if the process is set up correctly, if the design is set up correctly, then it will follow through. So yeah,
that's awesome.
That is so great. One of the things that when I first started getting into sustainability, I was talking to a friend of mine from Turner Construction, and I was asking him about carbon concrete. So apparently they were taking carbon and shoving it into concrete as a way for carbon removal. Sequester it. And he said it's impossibly expensive. Is that still the case?
I don't know. I have to be honest. Yeah. That's not something that I'm very knowledgeable about. I do know that they do it, but in terms of cost, I wouldn't be. I don't know. I'm more on the more on the MEP side. But it's a great point. I will say, like I said at the start, the last 10, 15 years, it was the MEP engineers where the focus was on, because it was all about reducing energy. Let's not use as much electricity. Let's not use as much gas. Now with the embodied carbon, the structural engineers are starting to get more involved, because they build the bones and the embodied energy is in the structure. So things like that are being looked at by structural engineers as possibilities to reduce the carbon footprint of the buildings that they design. So it's it really is an exciting time to be part of the construction industry. And we want to promote that so we get more people involved, right? And particularly more women, more people of color and things like that involved in architecture, in engineering, but also in construction. And it's great to see. And one of the last projects that I worked on was the LaGuardia project in Queens. And I was on site and I was super impressed by the amount of females that were out on site as part of crews, or who were in the offices with senior positions and running large parts of the project. It's great to see, because it's a fun. It can be. It can get toxic, right? There are moments in our industry, but I think every industry is the same. But it is an incredibly exciting place to be, especially with all this new technology and all these new buildings coming online. But also important, the reductive and reuse of buildings, like you mentioned earlier, Joel. We have a huge responsibility to not just knock down a shell that's already there, but maybe rethink and repurpose it so we can use what's already there to benefit a new application. So it's exciting times.
And I love the fact that you promote women in this workforce, because construction is historically men. I worked in, I started as an environmental consultant in the early 90s, mid 90s rather. And yeah, it was hard. I was one of the few. And you probably are aware of the Association of General Contractors, AGC.
Yeah.
So they do, every 2 years, they do this big event in Vegas where they bring in construction equipment. So imagine Tonka toys, but real size. And I fought like hell to be allowed to go. And I had the most fun. So when you talk about fun in the field, this is fun, because you get to play with these things and see like these giant cranes and giant backhoes. And it's just
Absolutely.
a blast. And I really wish more women would get into it, because we can have as much fun as the guys.
Yeah, 100%. Look, it's an industry that, you're right, is mostly male dominated, but it is changing. I've seen it even in the organization that I'm in. We've senior engineers that are running projects that are female. It's great to see. Some of the projects that I'm working on now are being run, like the senior architect, the principal. She's a woman. The owner's project manager, senior person there, is female as well. It's really good to see. It's definitely changing, but we need to do a little bit more to promote it in schools and things like that, because people aren't going into engineering or into architecture. There may be a shortage soon. Even the degree that I did in building services engineering in the UK, it ceased to exist, which I was really disappointed with, because people are just not choosing to go into it. They're choosing different professions. So, that's another responsibility that we have, is to go out there and to promote things and say, look, this is really cool. You could actually have a real impact on your surroundings and other people's surroundings. Buildings are big.
You can change the world.
Totally. But let's start. Absolutely. But we start off with communities. Even building a building that is a place for people to congregate, to meet, to discuss, something like that. If you're a part of building something like that, that has a huge impact on a community, and you're a part of it. It's nice to be able to take your kids along and say, hey, daddy was a part of that, that, and then explain it to them. I gave a 5-10 minute discussion at my daughter's class, she's first grade, for Earth Day, and I was blown away by how much knowledge these kids had on recycling, on waste. We got to turn off the water when the water's not running. Turn off the lights.
It's embarrassing, isn't it?
Yeah.
Kids they actually know a lot.
They know more than we ever did.
Look at Greta Thunberg. There's a young girl who's changed at 14 years of age, challenging some of the most senior male world figures and calling them out. It's great. It's we need more of that. It's good to see things like that come true. There are some pros to it as well. It's not all cons. So we need to celebrate the positives, accentuate the positives.
Absolutely. I'm going to throw you one little curveball to close us out. What's the coolest thing you've seen technology-wise in the past year? Like they were like something that blew your mind. You're like, holy shit, I can't believe they did this. This is awesome.
Oh, that's a good question.
I know.
You stumped me on that one. I'd say probably virtual reality. I'm blown away by how we can see it's kind of like looking into the future. Here is your building with all your stuff in it, and we can walk you through it before we even get onto site. I think I just think stuff like that is going to be amazing. And how scanning of existing buildings as well. So we can go in there with a laser scanner. We used to call it like a site visit. Go down, you'd be marking things up on a piece of paper, going, this pipe's running down.
Yeah.
You never get it accurate. It takes a lot of time. Now you can go in there with an expensive camera, click the button for making it easy, but it scans everything around you, and then you're able to put that into a model and then go. And that will help with reusing existing buildings, because we can then determine what we need to do with them and if it's viable to take it through to a different application. So yeah, VR and the sort of virtual world, the BIM world, I think is huge for us right now, and it impresses me what people are capable of doing.
That's awesome. I absolutely love everything you guys are doing, and hopefully we will see way more of you come out west. We got some projects out here that need some work.
For sure. I got to get some vitamin D anyway, so I need the sun.
Oh yeah, I'm out here and I'm pale as a ghost, so I need to get more too. But thank you so much. Appreciate it. And
Thank you.
this has been fantastic. It's so educational. And say hi to the family, give the kids a hug, and encourage the kids to start going into engineering and architecture. We need it.
Will do.
It's not going away.
Thank you very much for having me on. It was a pleasure speaking to you all.
Thank you. Guys, take care.
Take care. Bye-bye.
Bye, guys.